All righty, ladies and gentlemen, I'm going to show you how to deal with the lab exercise that I'm having you do. You have 3 tasks to do. You're going to do them 3 times. And the first task you're going to do is you're going to measure the volume of some sort of rectangular object in your house. I'm going to choose this tabletop right here. It's fairly rectangular. It does have one small problem, and that is that each of these edges has actually been kind of sanded down and has a, they call it a chamfer. And so when I go and look at how thick this tabletop is, I'm going to have to estimate where the actual tabletop is pointing on the ruler as opposed to where this buffed edge is. So I have a couple of tools that I might use. This is a really common ruler. You might have one. If yours does not have centimeters on it, you're going to need to convert from inches to centimeters. I'd like you to get the tabletop in centimeters cubed, okay? And I'm saying tabletop because I bet most of you have some sort of rectangular thing, whether it's a piece of furniture. Another thing you might have in your house, now I have a meter stick because I'm a science teacher, but you might have a yardstick, and you could do the measurement in inches and then convert. So you're going to be measuring the width and the length, which might require you to mark and then move the meter stick, or even if we want to use a tape measure, you could do that, and then measure the thickness. Now I want you to measure each of these dimensions 3 different times, 3 times in 3 different places. And the idea is you want to see how much fluctuation you get. If they're all exactly the same number, then that's great. But what's probably happening is that you're not interpolating correctly. You see, when you use a ruler and there are markings on the ruler, you get to estimate between the markings. So if the edge of the table is halfway between one of these millimeter markings on a metric ruler, then you could estimate that maybe it's halfway to the next one. So you would get an extra 0.5 or 0.5 or 0.005 on the reading. So 3 different places for the width, thickness, and length of your rectangular object. Then I want you to calculate the volume of it. The second thing you're going to do is you're going to use a stopwatch, and most of you have a stopwatch built into whatever smartphone you carry around. If not, you may need to borrow one that does have a stopwatch. I want you to time the same event 3 times. And again, want to see if you get the same results each time. The event that I choose to do is I'm going to roll this pen off the table. Now, when it comes to timing and using a stopwatch, there is a little bit of a gotcha to it, and that is there are 2 schools of thought. One is to press the start and stop button by anticipating the event as it happens. And so if I roll this off with my left hand, then as I see the pen get really close to the edge, I anticipate the moment that it's going to go off the edge, and I press the stopwatch button. And then I watch it fall, and as I see it approach the ground, I anticipate the touching of the ground, and I press the button just as it touches the ground. If you anticipate on both ends of the thing, you're going to get a very good reading. Now, if you don't anticipate, you react. That means that you wait until you see the pen leave the table and then you react. You'll have a short delay before you press the button, but you'll have the same delay if you, again, react to it hitting the ground. So I would roll this off the desk. It takes less than a second to fall, and I would start and stop the stopwatch 3 times. I don't expect you to get exactly the same reading because many stopwatches go to the hundreds or thousands of a second, and I don't think that you have the kind of skill to press it the same each time. So average out your 3 readings and report that. Also report what you think is the fluctuation. What is the difference between the average reading and, say, your largest or smallest? The third thing I'm going to ask you to do involves rolling around objects on the table and calculating pi. Now, you may not know this, but pi is not just a clever number. That's interesting. Pi is the ratio of the circumference to the diameter of any circular object. Now, I've chosen this particular can of whole green chilies because this can has a lip around the top and the bottom. If you choose a can of soup that has a lip on the top but the bottom is rounded, the can may not roll straight. It's going to make it very difficult because we're going to roll this can in order to find the circumference. So what we're going to do here is we're going to make a mark on the can, and that's why I brought this pen. Make a mark on the can, and I'm going to set the can so that the mark is down. Whoops. Okay, and I'm going to make a mark on the table exactly where that mark is. And now I'm going to roll the can. I'm going to roll it very carefully without slipping, and I'm going to roll it exactly twice. I'll tell you why I'm going to roll it twice. Because now I've rolled it 2 circumferences. If I can use my meter stick to measure this distance between the first mark and the second mark, I cut that distance in half and I've got the circumference. I've also cut the error in half. Now, this idea of doing multiple measurements or multiple rolls and then dividing is a great idea to get rid of measurement error. However, it does have a limit that if you roll it too far, you increase the odds of slipping and or you go past the length of your measuring instrument. So if I had just this ruler to work with, I would probably just roll it one time really carefully until it got to the bottom, and then make this mark, and then I would come over here and read it on the ruler. I want you to repeat this process 3 times. Change it up a little bit. Maybe you want to use 3 different objects, 3 different cans. Maybe you want to roll it once, twice, 3 times a lady, or you want to do the same thing twice and something different another time. But change it up, because the ratio between the circumference that you get off the rolling and the diameter, which you measure by just going across the fattest part of the can, should be very nearly 3.1415, blah, blah, blah. So for each of your measurements, your 3 measurements of pi and your 3 calculations of pi, I want you to find the percent error between the accepted value of pi and what you got through the process of rolling. Okay, so 3-part lab, tabletop measurement with 3 measurements of each of the 3 dimensions before you calculate the volume. The timing measurement, do it 3 times, whatever you time it 3 times, and then the rolling of the cylinder to find pi, and do that 3 times, whether with the same object or 3 different objects. I don't care much, but enjoy the lab. It will be due a week from today, and we'll talk about it later.